welcome to Redis Day Tel Aviv 2019. Pretty amazing. Thank you all for coming. I usually forget this, so I want to thank everyone who came and worked so hard to make this. I want to thank our presenters, Asia, Grace, Andrew, Redis Labs, our investors, our customers, and our users, everyone in the community, of course, thank you. We have a full day today. This is the fourth time in Tel Aviv that we're doing Redis Day, and we're actually doing more and more events over the years in other cities. Next month we have Redis Conf in San Francisco. Everyone's invited, of course. Sure. Oh. And last week, actually, about 8 days ago, we celebrated a major occasion in Redis's life. Redis has just turned 10. It's in the 4th grade. So we have a cake here that I'm going to cut in a very theatrical way. And everyone's invited later to grab a piece. Here's my knife. And happy birthday, Redis. You're welcome to sing with me. Happy birthday, Redis. Happy birthday, Redis. Happy birthday, dear Redis. I'll finish this later, like most of my tasks. Next, I want to invite to the stage Salvatore Sanfilippo, the creator of Redis, for regional introduction.
Hi everybody. Today I will try to show you what's the work that I did in the latest few months. We have 8 months to work to the release of Redis 6. The talk today will be very, very technical, like every talk I will give in the future, and it's the 3rd time that I try this approach, so we will see what are the motivations behind the features, what's the process, because we have something in mind, we make errors, we return back, change the design again, and we make new errors, and it's a back and forth process, and I want to give you visibility about such process. Redis is very open development because it's everything in GitHub. However, seeing the list of commits doesn't provide enough background information about what are the motivations.
Redis only have to do a single IOPS most of the time. It really depends on the size of the object, but usually it's single IOPS. On the other hand, disk-based database need to retrieve the data, traverse over the B-tree, so that means multiple traversal between the database and the storage, and it's about 50 milliseconds, if no more. This is like 100 times faster. And if you do a read operation, this is even faster because Redis doesn't need to do anything. You just serve everything from the memory. And this is 500 times faster than traditional data.
One is we have a log factor which controls how the counter is implemented. The other is the decay time, which tells Redis when and how it should decrement the counter. And the third is maximum resamples, which Elena spoke about that. It's mostly about how do you find out which keys to edit. So let's look at that a little more in detail. So first part of it, right? How do you implement the counter? If you look at the internal Redis data structures, Redis only has a counter of 8 bits. So if you want to track the frequency of an object, of a key, you only have 8 bits, which essentially means that you can only count up to 255, right? That's not a lot, right? I mean, real world use cases, the keys are going to be accessed much more frequently. But Redis only has 8 bits. So what does it do, right? And it uses a trick which is, it doesn't really count on every key access. It uses a probabilistic algorithm, and the way the algorithm works is, if the current counter value is low, the probability that it will be incremented is high, and as you keep incrementing it, at some point of time it will say the probability is low and it won't increment with that frequency, right? An easy way to remember is, let's say that you take a coin and you flip it 10 times, right? And you get a head 10 times in a row, right? So what will that tell you? It basically tells, if you get a head 10 times in a row, it means that you've tried to flip the coin that many more times. So it's a way which basically says that I'm not going to increment the counter every time. I'm only going to increment it based on the probability. And then what that means is, let's say that the counter that you see right now is, let's say the counter that Redis has is 10.
See that replica 1 sends the information to replica 2 with the key and the value. So replica 2 receives it and tells the Redis search on replica 2 to index the data. So if we do a search command on replica 2, we will get the data, which is as expected. We are doing a search command for HANA and we will get the data. So now
as a continuity to Meir's talk, I'd like to present to you the results comparing Redis Search to Elasticsearch. I'll present myself. I'm Keren Waknin. I work on the performance of Redis Labs products on the CTO team. And I'm very excited to share with you the results we've measured on Redis Search. Okay, so let's go. As part of this presentation, I'm going to go over a couple of use cases. Then we'll be talking about the main differences between the technologies of Redis Search and Elasticsearch. We'll discuss the configuration settings of each platform. And then I'll explain how we're conducting benchmarks at Redis Labs. Okay, so in the first use case, we're measuring the time it takes to build an index and to do a simple search of 2 words. Measuring the time it takes to build an index is important. We've seen that on a dataset of 5 gigabytes, it's a wiki dump that we've taken earlier this month, containing 5.6 million documents. We measured the time it takes to build the index. So the index is basically you have a bunch of words and you are building an inverted index for each word, which document is the word contained in. And what we've seen is that for Elasticsearch, building the index took 349 seconds, and for Redis Search, it took 221 seconds. So it's about 58% faster. And that's exciting. It's our developers, right? Just clarification. So the performance of a search, as we said, we had many words, and we were able to build the index that we just talked about. So the list of words and the document in which they are contained. Great. So now we can actually look for two words within that index. Very cool.
Using JavaScript and TypeScript, so it's doing the job for us. This is one of the features that we provide. Also, the schema that might be very large is possible to be constructed in a modular way. So each team can create their own part of the schema, and very, very easy deployment stage to production. We use Docker, you can use AWS Lambda, and spin it up in a matter of minutes. Installation is available via NPM, Node Package Manager, and installing the package is pretty much straightforward. You'll see a very short demo, this GIF. So after installing this tool, what you can do, this is the GitHub page of the repository, and you can start by running GGA, generate GraphQL app init. It can spin up a new server for you with all the configuration ready for setup. So you can select between two available boilerplate projects. One of them is for Docker environments, the other one is AWS Lambda. It will clone the project, everything is set up for you. And the next thing that we're going to do is, it's not seen here, but you can add entities that you want. It's pretty much inspired by Angular CLI. And here we're able to introspect the data in our playground. So this is pretty much easy. And the other features that we're allowing the user to have is to easily add a new entity, easily add connectors for things like Redis, using Node.js as the primary development environment. So this is pretty much the road that we've had for creating our own API layers. We have felt that it enables us to have shorter development cycles of adding new entities and features, and also a way to let every team do what they do best. The full-stack development teams are now doing full-stack JavaScript. They add entities and they use a GraphQL layer that they're already familiar with. The backend teams are using the old PubSub protocol for interacting with different microservices, and this has improved dramatically for us, and this is it. Thank you.